Okay, let's have another example. So this time, another algorithm with two parameters, the x and y. And then this time, we're going to use nested recursion. Nested recursion means we have more than one testing conditions to be executed in performing the recursive call. Then we have here options of how are we going to call the function fun. Okay. Okay. So let's have first letter A, calling function fun3 with a value of 10 for x and a value of 4 for y. So for that solution, it's very easy. Okay, so we're going to uh, send the value of y and x here. So this is 10 and 4. So the solution for this is just simply if x is greater than y, so is 10 greater than 4? Yes, so it will just return -1. That's the solution for the first one. That's the only solution. And then for the activation record, we have x equals 10, y equals 4. So this will be return -1. So here, I'm going to put -1. So we only use one activation record for this solution. Okay. For letter B, so this is letter A. So for letter B solution, again, we're going to use 4 as our x and y is 3. So again, the same answer. It will just return a value of -1. And then from the activation records, we're going to use return -1. Then here, I'm going to use and type -1. Since 4 and 3, again, is 4 greater than 3? Yes. So it will just omit the other testing condition and just will return a value of -1. So that's the solution for letter A and letter B. How about letter C and letter D? So for letter D solution, letter C solution. So we're going to send x as equals to 4 and y equals 7. Okay? So in this solution, going to use 4 and 7. So we're going to test, is 4 greater than 7? False. Is 4 equals 7? False. So this time, I'm going to use this equation. Okay? So that's become equals, okay, x is what? X is 4. Okay? And then multiply. And then I'm going to use fun3, parentheses, okay, parentheses. So within the parentheses, I'm going to put the x plus 1 and the y value. Okay, x plus 1 and the return value. So x plus 1, that's 4. Sorry, x is 4. Okay, and then plus 1, this becomes 5, comma 7. Alright? So that's the return value. Okay, so at, at first, the first equation is 4, which is x, and then fun 3, comma, 4 plus 1 is 5, comma, y is 7. So again, another instance of a function on this particular area. So I'm going to use, again, 4 times. Okay, and then I'm going to use brackets. Okay, so we call here, and now this time our x is 5. Okay, still the value of y is 7. So is 5 greater than 7? False. Is 5 equals 7? False. Again, I'm going to use this. So this time I'm going to put it here in the bracket. So this becomes 5 times fun 3, parentheses again. Okay, so within the parentheses, we have two parameters, the x plus 1 and the y. So x plus 1 is simply the value of 5 from the previous equation. 5 plus 1 becomes 6. Okay, then comma, and then the value of y, which is still 7. So again, another instance of a function here. So I'm going to put 4 times bracket, 5 times another bracket, Okay, and then bracket. Okay, so here, we're going to send again, now the parameter 6 and 7. Is 6 greater than 7 false? 6 equals 7 false. So again, this particular algorithm we're going to put within the bracket. So x is 6 times fun 3 parentheses. So this time, x plus 1 becomes 7 comma 7. So we have another instance of another function. This time, fun 3 7 7. So this becomes 4 times parentheses 5 times as bracket 6 times another bracket close close. Okay, so this time we're going to return 7. So in this case, if 7 greater than 7 false, else if 7 is equal to 7, so I'm going to return positive 1. Okay, so again, based from the equation, we're going to first process 6 times 1. So this becomes equals 4 times bracket 5 times another bracket. So this is 6 close. Then again, 4 times bracket 5 times 6 is 30 parentheses. And the final answer here is 120. Alright, so how are we going to implement it here in the activation record? So again, x is equals to 4, y is equals to 7. So we're going to use this particular statement. So this becomes 4 times 1, 3, parentheses 5, comma 7. So another instance of a function. So that's why we have to create another activation record. So is 5 greater than 7 false? Is 5 is equal to 7 false? So we're going to use the else statement. So again, that's 5 now times 1, 3, parentheses, 5 plus 1 is 6, comma 7. So again, another instance of a function. So we create another activation record for that. This time, x is 6. So is 6 greater than y? 7 false. Is 6 equals 7 false? Again, we're going to use the else statement. So this is 6 times 1, 3, parentheses, 7, comma, 7, parentheses. Again, another instance of a function, but this time we return or we use the parameter 7 for x. So again, is 7 greater than 7 false? 7 is equal to 7. Yes, I'm going to use return 1. So meaning, I'm going to return the value of 1 here, and we are going to use 1 in fun 3, 7, comma 7. So this becomes 6 times 1. So the return value is 6. Then we're going to use again 6 to multiply to 5. Then the return value is 30. Then again, we're going to use 30 to multiply it with 4. The answer is, or the final answer is 120. So again, the solution for the equation as well as in the activation record are just the same. Okay? And then, how many activation record did we use? Except for this, for the first, we use 1, 2, 3, and 4 activation records. And finally, the last example, letter D. So this time, I'm going to use 0, 0. So this is very simple. Okay? So if this is 0 and this is 0, is 0 greater than 0? False. Is 0 equals 0? Yes. So I'm going to return only a value of 1. So again, in the activation record, we are going to just type return 1. And then here, I'm going to type 1. So here, we only use a single activation record. Okay? So if you have any questions or concern regarding this topic, you may send me a message through my messenger, or you may also send in the course message within Blackboard. So this time, for this particular example, kindly try to answer, okay? This is the algorithm, and then what if my x here is 4, and what if my x here is 10? Okay, so this is already a clue on how are you going to do the activation record, but you need to find the solution. Then check whether your solution from the equation is the same as the activation record. Then later on, after this video, I still have one part of the video, which is the answer for this problem.